the keynotes this morning. So welcome to Bangkok. My name's George Gray. I think most of you know me. I'm CEO of Linaro. We've got a lot to get through, so I'm going to go straight into it. Firstly, why do we need Linaro? We're all getting pretty good at upstreaming. We've all learned a lot about open source in the last 5 years. So do we really need Linaro anymore? And the answer is definitely yes. Well, I would say that anyway. But if you look at ARM's business model, more than ever, it's leading to an unprecedented level of innovation in silicon and SoCs. And if you look at Intel's quarterly R&D budget, the amount they spend on R&D every quarter is more than twice ARM's annual revenue. ARM sells IP, it doesn't sell chips. So Intel is making a huge investment, quite rightly, in software. Software is the most expensive part of delivering a product today. And in order to be able to compete with that, we have to harness the revenue and the ability of all of the ARM SoC vendors and the ARM ecosystem to compete with that level of expenditure. But we can't do it individually, or we'll all be doing the same thing again and again and again and wasting those resources. So Linaro is where the ARM partnership works together to invest in software for the ecosystem. Our mission is to lead collaboration in the ARM ecosystem. If you look at some things that we've been noticing over the last couple of years, our initial focus was in the mobile space. And the mobile space continues to drive new technology across the ecosystem. ARM is now found everywhere, from sensors all the way into the data center, and everything in between. And open source software is critical in all of the market segments, from smallest Cortex-M all the way up to the data center server SoCs. And product developers, people delivering products commercially, need a good starting point. They need multi-vendor solutions and choice, not only a price, but also performance and functionality. And they need that for devices, they need it for gateways, and they need it for cloud solutions. Everything today is connected from the device through some kind of a gateway and up into the cloud. So Linaro as well is grown to focus on end-to-end ARM-based solutions. And you're going to see more and more of this over the coming year and years. From IoT, where we have the Linaro IoT and Embedded group that we're in the process of forming, to mobile, to the digital home, to networking, and to the data center itself. And I'm going to talk briefly about each of those. So IoT and Embedded is a proposed new Linaro segment group where we already have an interim steering committee formed from companies interested in this group from all over the world. And we have project scope and actual technical work already underway. Part of what we're going to be delivering is a reference IoT software implementation across both Cortex-A for devices and Cortex-M microcontrollers. And this will include industry standard and agreed protocols and security that the members of this group define and specify, and it will include open source software implementation all the way from the sensor to the cloud. At the end of the day, the business model around IoT is around what you do with the data. It's not around trying to make money out of the operating system that sits on the device. That is going to be an open source platform that everybody is going to use. In mobile, we have a continuing focus on the mobile area because volume competition and consolidation is still driving a huge amount of effort and innovation in the mobile device. Everything is mobile. And most of that work today in LMG is obviously based on Android, but we're very pleased to have Acadine as a member of the mobile group, and they're doing innovative work with their operating system, H5OS, which uses HTML5 as the application platform. An effort is going on in performance, power management, and footprint. And this functionality finds its way across the entire ecosystem. So reducing the footprint helps make lower cost devices in the IoT world. Increasing effectiveness of power management is actually needed in the data center as well. As more SoCs come into the data center, the importance of power management, given the amount of power that these data centers use, is becoming more and more a requirement. And so these features that we're developing today in mobile are finding their way across the ecosystem. In digital home, we continue to work on open source platforms, both Android and the Comcast RDK. This year we're expecting to do a lot of work on China tvOS, which is sponsored by the Chinese government as a standard open source platform, not only for China, but for global use. And the focus in Linaro is primarily on security and media frameworks, which is where the SoCs vary widely, and creating common APIs and a common platform for delivery of security, both for media and for the device itself, is a key focus. In networking, this for us is the year of ODP. There are two major ODP Open Data Plane releases planned this year, the Monarch release at the end of Q2 and the Tiger Moth release at the end of Q4. This is not so much about piling on new functionality, this is now about deployment. And I'm very pleased to see members start to deploy applications based on ODP, not only members, but also other companies in the ecosystem. And I think you'll start to see a focus on it from LNG on the applications for ODP in devices such as top-of-rack switches, smart NICs, and edge devices using NFV. So this is where you have a device that's connected to a dedicated network, a piece of hardware, where ODP comes into its own, providing a common API for completely different accelerators for manipulating and managing network packets directly. So ODP is going to be leveraged for hardware acceleration across a wide range of devices. In LEG, we're focusing on the platform for the data center. And this is all about ARM SoCs in the data center and beyond, and cloud computing, both private and public clouds. A lot of our effort has been on firmware. That is going to continue because as SoCs continue to innovate and create new features, we have to make sure that they can run standard operating systems. And that means different features have got to be brought into ACPI, UEFI, and support for those features as they become available. But we're also focusing on the whole stack. And I'm going to talk a little bit about this later, but we're doing a lot of work on OpenStack, on OPNFV. OPNFV also requires the use of standard NICs, completely standard data center implementation, so that includes DPDK. We'll be using that. We'll also hope that the work in ODP will also eventually be able to be a competitor in this space to DPDK, but DPDK is needed now. We're also working in big data with Hadoop, Spark, Mapper, and then in high-performance computing as well. So all of that is being done in the enterprise group. So moving on, how do we deliver all of this software? The 96 boards program has evolved hugely over the last year, and since the last Connect, a lot has happened. The point about 96 boards is it's a key enabler for the reference software platform. It's a key enabler for us to deliver examples of software on multiple vendors' hardware. And it's also going to be a key enabler of the Mezzanine ecosystem, which enables peripheral sensors and I/O vendors to build products and make sure they work on multiple SoC vendors' hardware, ranging from IoT devices to the data center. And there are three versions of 96 boards that we're defining. Today we have the consumer edition and the enterprise edition. We are currently in discussions with the light steering committee about an IoT edition, which will enable us to provide common platforms across different Cortex-M vendors at price points of well under $10 for a minimum configuration. But this, again, is very important to allow us to enable development of sensors, peripherals, and devices that can connect to a wide range of SoCs. So I'm very pleased that we're starting to see more 96 boards products. Today, in the Consumer Edition and Enterprise Edition, we have the Qualcomm Dragon board, we have Marvell's board, which they're using for IoT applications, Lamaker's HighKey, and recently started shipping UC Robotics Bubblegum 96, which is a Action Semi board. We also have the Husky board that's taken longer to get into production than we would have liked, but we're going to show you some exciting things about the Enterprise Edition boards later in this talk. We're also starting to see the mezzanine boards develop. We have mezzanine boards available from ST and from Seed for connecting sensors to 96 boards. And today, you're going to see the announcement and demonstration of the first display for the CE edition from Lamia, a 7-inch touchscreen LCD display. So I do want to talk a little bit about two particular boards. The first one is Dragon board. This is built by Arrow. It uses the Qualcomm Snapdragon 410E, which is for embedded, and both Qualcomm and Arrow have done a terrific job in getting support for all of the major operating systems for embedded and mobile devices, and also supporting IoT platforms. So in operating systems, Android, Debian, Ubuntu Snappy, Brillo, and Windows 10. And the IoT platforms that are supported out of the box include AT&T M2X, Amazon Web Services, IBM Bluemix, and Microsoft Azure. And you can go and buy one of these boards and be connected and delivering data and receiving data from these cloud systems very quickly after opening the box. It's very impressive. So this board is seeing rapid adoption and significant volumes already. I'd also like to make an announcement on HighKey, which is something that a lot of people in Linaro have been working at for a long time. And today I'm very pleased to announce that support for HighKey, which is a 64-bit Cortex A53, 8-core, 96-board CPU community board, is now available in the AOSP source tree today. And if you go to that URL, you can see an announcement about this from Google. Special thanks to a huge number of people in Linaro and in HiSilicon, including particularly John Stoltz, the landing team for HiSilicon in Linaro, and the guys in HiSilicon on that team as well. It's been a joint effort. This is really exciting because it hasn't been since PandaBoard a few years ago that a community board with real support in AOSP moving forward has been available. And this will help developers and peripheral vendors and accelerate adoption of their devices into new Android versions. We hope that we can extend this program with Google to other SoC vendors in the coming months and years. I also want to introduce briefly the reference platform. This is something that, with the approval of the Linaro Steering Committee, we've started since the last Connect. And this is about providing end-to-end reference implementations of open source software. It's connecting the hardware and the pieces. It provides a cross-SoC, multiple SoC reference implementation from firmware to application use cases. But why would we do this? Why should Linaro be delivering what's getting closer and closer to a product? It's not a distribution. We're actually including distributions in this software. And the answer is because we need a reference how-to implementation. We need product vendors to be able to deliver products faster, to be able to spend more of their own engineering resources on their value add and not on doing the same thing as everybody else. If you think about the enterprise space, all of these projects, whether it's the distribution, whether it's the kernel, whether it's the firmware, Hadoop, OpenStack, all of these projects are moving at a very rapid pace. And if you're asking a product vendor every time they want to create a product to have to put all these pieces together again and again and again, and they'll be completely different at a different time and at a different company, that's an awful lot of wasted resource. So over time, we think that if we can create a platform that delivers these standard pieces as a starting point, it will improve product development cycles and enable a wider range of ARM SoCs to be used across the ecosystem. And over time, you'll benefit from multi-vendor and community participation, making it better and better. So this is tested and built on 96 boards and on selected member hardware. And today, we've done now 2 preview releases for mobile and embedded and enterprise segments. The first one was at the end of last year in December. The second one, due to a huge effort by a large number of people in Linaro, was made this weekend just before Connect. And you can go and see it on the website on the Linaro downloads page today. It includes the latest Linux distributions, Android, Debian, CentOS, and is available from end to end, from firmware all the way through to application. And the IoT digital home and networking groups are looking at creating specifying reference platforms for their own segments for delivery later in the year. The goal of these platforms is we provide source code. We provide the recipe for how we did it and what we've tested, what's functional, and we will be able to support the community in using these platforms. And it's designed to be easily ported, not only to new member SoCs, but also to the rest of the ecosystem. We will be delivering this on a quarterly release cadence. One key thing that was done over the weekend in the new release was that we finally have a unified kernel tree across mobile and embedded all the way up to enterprise. There's a single unified tree that supports HighKey, Dragon Board, Huawei's D02, APM's X-Gene, HP's ProLiant M400 system, and AMD Overdrive. It's taken a while. So huge kudos to the entire team in Linaro who've been developing technology over the past years to make this possible. We're finally getting better at this. And it is 4.4 based. It will continue to move forward as Linux moves forward. It does include under review topic branches to enable hardware support that's not yet upstream, but the goal is to get closer and closer to upstream for a wide range of our member hardware. It includes device tree support for the enterprise, for the mobile and embedded markets, and it includes UEFI, ACPI, and PCIe support for enterprise in a single kernel configuration for all platforms. First time. Good job, guys. All right, the next announcement I want to make is that Linaro is producing a developer cloud implementation. This is a Linaro cloud for developers. Why are we doing this one? Well, again, it's a how-to. It's a full open source implementation that can be used as a starting point for creating public or private cloud based on ARM technology. And the goal here is to provide public and restricted access to new products for software developers and end users who want to try out ARM servers in a safe way. It's for developers, ISVs, and end users to evaluate and utilize our members' hardware and provide them a place where they can ask questions about gaps or about performance issues, and we can get them to the right place and get them fixed and make this better and better moving forward. And even better, we're delivering an entire cloud implementation from firmware all the way to the OpenStack implementation and implementations of OPNFV and so on, and we're doing it and we're providing the source code so people can see what we've done and can replicate it in their own companies. So we think this will accelerate adoption of ARM into real commercial cloud implementations. That is our goal. This project is probably going to last for a couple of years until ARM is widely adopted in those commercial providers. This is going to be run on Linaro and member partner facilities. So today, we're announcing the developer cloud. We're running it in Linaro's Cambridge facility and also in our Colo facility in Austin, in Texas, in the United States. We expect to extend this to China in Q2 or Q3, and we expect members and member partners to participate. And all of these instances can be federated, and users will be able to request and purchase instances, just like a real commercial implementation. But it's for developers, and it's by developers. And again, this is on a quarterly release cadence. We're releasing the source code for the entire implementation as we go along. Congratulations to everybody at Linaro who's worked so hard on making this one happen as well. So, I now want to ask some of the Linaro team and also some of our partners to come up and do a couple of demonstrations of some of the things I've been talking about. First, I'm going to invite Tony Zhang from Lamia to come up and demonstrate the display I talked about earlier. Tony is from Lamia, based in Shenzhen in China, and they have developed the first display kit with a display and integrated 96 boards mezzanine interface. It's a 7-inch display, 1280-800 pixels with a touch screen, and its target availability is in May. Tony, do you want to show it to us?
Okay, hello everyone. I'm Tony from the Maker, and here I'll demonstrate the 196 mezzanine LCD kit for the HighKey. Okay, the mezzanine LCD kit have two parts. One is the adapter board, and one is the LCD display. And in my hand, this is an adapter board. And on the bottom, there are two connectors. One is for connecting the low speed on the Lightning 6 board. One is to connect the high speed of the Lightning 6 board. And on the front, there are three connectors. This one is to connect the LCD, and this one is to connect the display, to connect the touch screen. Now, and it is easy to use. We just connect the adapter board to the HighKey, and just like this, and then to power on the HighKey board with LCD. I'll demonstrate how it works. Now, because I have already set up this device, okay, and then we can. Okay, the LCD is already lit on, and I can show you just a little demo, play videos on the LCD, and to demonstrate the display performance of the LCD kit. Okay, thank you.
Thanks very much indeed, Tony. Very excited to have this product, and of course, it will not only work on HighKey, but also on Dragon Board and other 96 board CE implementations. Next, I'd like to invite Yang Zhang, who's the director of 96 boards at Linaro. He's going to show some very early work that we've been doing on VR, and particularly the fact that we can develop and deploy on a single 96 board $75 product. And in order to do this, he's going to be demonstrating using HighKey's 2 GB RAM CE board from Lamia. He's using OSVR's headset and tracking devices, which are available off the web for those who want to at a relatively low cost. And the software here is the reference software platform with Debian and the OSVR VR stack with the OSVR core and SDK, Mesa driver, OpenGLS 2.0, and Open Scene Graph. So Yang, over to you.
All right. Okay. I hope you can hear me. So I'll be taking my glasses, so I won't be able to actually see you guys. Hope that's all right. Okay. Right. So the reason why we're actually interested in this is because we are seeing adoption for 96 boards and from basically everywhere. We have been contacted with our partners and developers to develop a wide range of applications. And now we're actually thinking about why we are focusing on the I/O control, and why don't we explore the boundary a bit, push the boundary a bit further, exploring some of the really interesting applications. So we look at, we know some of the partners are working on robotics, working on drone designs. I was thinking actually, we can actually bring this to the virtual reality as well. There you go. It's a very simple demo, but the core concept is be able to having all the tracking possibility and also the rendering and the 3D graphics in this demo. One of the key things behind this very simple demo is actually a very powerful concept. And for the first time, because normally when you're working on a VR application, you will be paying around $600 to $800 for the headset, which is closed designed. You were spending another $1,000 on a PC to actually get you started, be able to work on any application or any of the concept proof in the early stage. So the whole set of this has been developed with a single HighKey 2 gig RAM 96 board without any intervention of the PC. So this costs you $200. This costs you $75. There you go. So that's the whole set. Okay. So one of the things we are looking at is that in particular we select this headset OS VR. It's an open specification of the hardware itself. Also come with the OS VR core implementation of the software stack. So again, end-to-end, fully open source, where community can take advantage of based on HighKey 96 boards.
Okay, thanks very much. All right. Thanks very much. So Yang has promised me that at the next Connect, we're going to use the same hardware, but we're going to actually be playing VR games. So looking forward to that. If anybody does want to start experimenting with VR, this is a very low-cost way of doing it with a very powerful system. Next, I'd like to invite John Masters, who most of you know, to the stage to demonstrate Red Hat running on Red Hat's Server Edition 4 ARM 7.2 developer preview, the real Red Hat unmodified running on the CircuitCo Husky board. John.
Thank you. All right. Don't go anywhere. Turn around. Selfie with the audience. Come in. Woo! Yeah! All right. How you doing this morning, guys? Doing good? Yeah? Excellent. This is me on 2.5 hours sleep. Could you imagine? So I'm John Masters, Chief ARM Architect at Red Hat. And actually, the fun thing about being here this week is that it is our 5th birthday for the ARM team within Red Hat. So we've been doing this for 5 years. And I've been coming here and doing fun little demos over the years. Today's demo is particularly interesting because what we are pushing obviously is standards. Hands up here if you have never heard me rant about standards, right? I will fix that for you, Mark, and I will send you email about it later, okay? So obviously, I'm very keen on standards. We're pushing standardization as the path for success of ARM at scale in the enterprise, in the public cloud, in data center. And one way we do that is by having industry standard operating system releases that run across a wide variety of platforms, including the Enterprise Edition 96 board, in this case called Husky, This is an AMD Opteron A1120 SoC, quad-core A57. It's got gigabit Ethernet, it's got USB 3, it's got PCIe and SATA, it's got all of the standards that I love. It's got everything. It's got UEFI, it's got ACPI. What more could you want in life, right? And it's running Red Hat Enterprise Linux Server for ARM 7.2 development preview, which rolls off the tongue, right? And just to kind of make it more exciting, what we've done here on this board, which, you know, you put this in a case, you hook it up and whatever. Do you want to hit the button? No, the video feed, sorry. There we go. All right. So we've got here the board running. We've got the ARM server SoC here. We've got some RAM. We've got a disk that I've attached. You'd obviously put this in a case. And just to make it interesting, we're not using the onboard network today because I wanted to demonstrate to you that we could put an off-the-shelf network card in the PCI slot, and we can use that. So we've set that up. We're not relying on the network, the Wi-Fi network here for obvious reasons. I have a hidden one that some of you have been trying to connect to anyway. So hopefully it still works. Okay. We're going to switch back to, is it number 1? No, the video. Number 1? Okay. So what I'm going to do is I'm going to log in. Hopefully it's still, oh, there we go. Okay. So I'm logged in here over SSH into the Husky board. Let's go ahead and do, okay, so this system is running the 7.2 release of RELSA development preview that we released in the fall of last year. It's got a 4.2 kernel. We've not modified it. We've done nothing to it, which is awesome. It just works because it's standard. It's great. And let's show you. It's running 7.2, okay? So over time, you will see RELSA supporting more of these platforms, and that's awesome. Just to show you we do something interesting with it, I'll pull up a web server here. I've got the obligatory WordPress running on here. You guys can take a look at that this week, play around with the boards. George will tell you a bit more in a minute about how you can get them. I just want to say a couple of thank yous to people before I hand back to George. So I'd like to say thank you very much. Is Leif in this room? Leif, are you here? Where's Leif? There? Stand up. Everyone give Leif a round of applause. Woo! Leif has done tremendous things for the firmware on this. Yang has done tremendous things. George has done tremendous things. Steve has done tremendous things. Saravi, stand up. I know you're in the back there. Do it now. Up. Thank you. Thank you to AMD. Thank you to everybody else. We can talk more about the awesomeness of standards and of Red Hat's products later in the week. Thank you, George.
Thanks very much, John. It's exciting to see this actually coming to fruition at last. But I also now have a further announcement, which is another new product introduction for 96 boards EE. And this is also made by our partner Lamia in Shenzhen, and is called Lamia Cello. This is also an AMD Opteron 1120. It's a 4-core SoC. You can also get 8-core versions of this SoC, but these boards have the 4-core version to keep the cost down. It has the same functionality, gigabit Ethernet, USB 3, PCIe SATA, same firmware, and is 100% software compatible with Husky board. Best of all, you can pre-order it today when you can get on the Wi-Fi. And it's being delivered. We expect it to be delivered in Q2 for $299. I have one here, which I can show you. I will put it on the camera in a moment. But please, if you're interested, place your order because I think the first batch will not last very long. And please feel free to meet up with Tony, who's here all week, and talk about what Lamia have been doing with this board. So we're really excited because this will run the reference platform, Debian, CentOS, will run Red Hat, and is a very low-cost way of getting access to real server hardware. So let's just put that on the camera. John is now in the process of pre-ordering one. Okay, so for the final demonstration, moving along, Martin Stadler, director of the Linaro Enterprise Group, is coming up. He's going to show us the developer cloud, which we announced just now. He's going to show you OpenStack running. He's going to launch a server instance from Austin in Texas, and he's going to connect to a commercial product sitting on top of that cloud implementation called OwnCloud that some of you will probably have used. We're going to run a photo uploading competition all week on these instances, and Martin's going to give us a quick update each day as to how things are going. I really want you guys to take photos, upload them, and there'll be a prize for the best picture of the week. And most interestingly, all of this is running end-to-end on ARM. Martin.
Great, thank you. All right, so let me give you a little overview of what we're doing. How much screen do I have? All right, so this is, if you've run OpenStack before, this is nothing exciting. It is just OpenStack running on a very standard-based server platform. The difference is it's running on ARM, and it's a reference platform with our member server kit in both locations, Cambridge and Austin. This is the one in Austin. So if you can look here, you can actually see that we're running quite a bit. This competition is also for us to test our metal, so you are all beta testing for us. All right, just give you one more idea of what we're doing here. Scale-wise, we think we're going to be able to scale these guest environments to initially 200 to 300. We expect to be able to do a lot more than that. The network is slow. I apologize for this, but it's a demo. Yeah, everybody shut off your Wi-Fi. I'm kidding. All right, I'm going to go ahead and just launch the instance, and then we'll come back to that thing. How many of you, raise of hands, know about OwnCloud? Couple? Come on. All right, so we're doing this a little differently on the enterprise side. If you can see, this is what we're running in the cloud today. And if you look, you can, all the big sort of circles, those are just systems that are just running, beating the metal, as it were. And then we've got the brown sort of area, that tenant. That's our own cloud area, so it's running Memcached, it's running Nginx, it's running Apache. What else do we have? We've got our NFS mount points that are out there. So we're doing this in a real sort of way that you've got a big environment. All right? Can we go to the, I'll just show you this. Because you want to win a prize, I just need to give you a little overview of the interface itself. When you log in for the first time, you're going to use your Linaro Connect login. You're going to want to put your photos in the Connect folder, because if you don't, we're not going to look at them, and then you won't be able to be eligible. Can we switch back to the slide deck? All right. So this is what you have to do. Once we get the Wi-Fi in, you're going to go to bkkcloud.linaro.org/OwnCloud. That's if you're on a web browser. You can go to the Google Store or iOS App Store, download the OwnCloud app from there. You're going to use your Linaro login. And if you don't have a Linaro login, you could just go ahead and register right there at that link that you can see. You're going to download the app, you're going to take a picture, and then you're going to upload it to Connect, and come Friday, we will announce the winner. We're also going to go ahead and show different photos for the day, so make the effort, take some time, take some pictures. Remember, this is public, and everybody can see who it is who uploaded the photo. Yep.
Into the Connect folder.
So I'm going into the Connect folder.
Now, I was very rudely on my phone, 5812, and just took a photo, one of the first photos of Martin, and if we can persuade the Wi-Fi to give us enough bandwidth.
There we are.
There he is. That's uploaded into the cloud. ARM end-to-end.
Very, very briefly, a lot of people did a lot of hard work to get this done, so the reference software platform, we wouldn't be able to do it without it. So folks like Ricardo Amit, Graham Gregory, Leif, I've got the software-defined infrastructure team that's done a lot of things. There's a lot of work that's been put into this effort here. It's not trivial, but we've made it so it's simple for you, okay?
So really, thanks very much indeed, Martin and the whole team. So there it is, end-to-end, running on ARM, unless you're using an Intel laptop or an Intel phone, wouldn't recommend it, but it will all just work, right? And hopefully, if you guys upload lots and lots of photos, Martin will give us some stats on how things are going in the colo over the next few days. Thanks very much, everybody, really excited about that. So thank you for listening to this, and we're really excited to be here. I think we're going to have a great week, and we're going to start off the week with Eric Henenhafer, who is the VP Research at ARM, who's going to give us a little bit of insight as to what ARM are doing in some of the areas that we're working on. Thank you very much.